Thank you. Omer, are you here? Can you respond? No response. All right. Assalamualaikum. Very good morning to all of you. Thank you for coming. I think today we have a complete set of students, around 20 of us, 19, excluding me. Okay, in total, based on my list over here, I have around 20 or 19. I think from IMSWEB, I have 19 students. But here, I don't know why 21. Maybe guest user was is included in this for the total number of participants in our course. All right. While it's our new student from Qatar. So I believe he cannot log into e-learning because of some difficulties. I think because of his email. I hope that Omer, you can contact Digital Care and state your problem in the email to Digital Care. Also, Izaidi, as I mentioned earlier, I've already give you the email address for Digital Care at utm.my. Please contact them and state your problem. For the rest, I think we have few more new students like Afiq, like Tana Sabari, just being able to access our e-learning portal. Welcome to the class. Also, I think Adam Kushari, also our new student, just registered in second or third week. I not remember, somewhere around that week lah. Okay. Also Karu Yoshino from Japan. He is non-graduate student. Maybe he can team up with Nakanishi Toshiki, or can ask Nakanishi. I think that he left in the past few weeks. Okay, that's for updates of participants. Okay, we have a look at our course. For those who are new, basically, we are already in week 3. Where's week 3? Oh, sorry, week 4. And last Tuesday, we already discussed about Supernode as well as introduction to DC circuit theorem, which consists of source transformation and superposition. For those who able to log into e-learning, you can find all materials of the course so far up until week 4, and also have a look at the videos that I posted. This is not the lecture video. The lecture video, I think I will post it towards the end of our semester, because I really appreciate that you guys come to my class. So if you would like to do revision, you can always go into the lecture notes, and also please make sure that you attend all of our classes. For those who have already missed, what to do? Maybe it's still okay, because the material you miss so far is not something which is a rocket science. you can always have a look at the lecture notes and have a look at the textbook that someone in our WhatsApp group posts on Tuesday. For those who already got the book, yes, congratulations, very good. For those who still did not download the book, please do so and ask your classmate or colleague to share the textbook. Okay, for today's session, basically we are in week 4 and we already finished our lecture material up until superposition. And I also, this is a reminder for you guys, I also put a class activity week 4, if you can see in the third posting over here. You need to download the question and do the exercise inside the class activity number 4. And please submit by tomorrow, 11:59 p.m. Okay, for today's class, what I plan is I try to do some tutorial or exercise, do some revision, because some of you guys still some of you guys just came into this class. Maybe this sort of tutorial or exercise will keep you guys in the pace of the class up until today. Okay, for the questions, can you please download this tutorial now? Let me see participants. Can you please download tutorial question from e-learning? Oh, okay. Sorry, you guys. I have to answer a phone call, very important phone call. Very sorry about that. Have you download the exercise?
Yes, sir.
Okay, thank
Yes.
you. Okay, this is the question, right? Right?
Yes.
Yes.
Okay. All right. Now, what I'm trying to do for the first 20 minutes, I will leave you guys with the question. Um, Try to answer the question, and I will call upon one of you guys to present your answer. Is it clear?
Yes.
Okay.
Okay. So try to answer question number one first. And if we have time later on, maybe uh, we will proceed to question number two. But before we proceed to question number two, I will try to explain the answer for question number one. And before I explain the answer, I need you guys to have to do it by yourself first, and then present your answer. It's not necessarily a correct answer that you presented to me, but at least I want to see your effort, and then how how is your understanding about how to solve this kind of question. Basically, this question is taken from test one a few years back, maybe. This is my question bank. So you should expect that in your test one, the question might be looks like this lah. So that's why I need you guys to have a look first for 20 minutes. I will give you guys the time to answer 20 minutes, and we will get back to the online session at 11:45. If you, I will stay in the online session. If you would like to stay, then also can, or if you like to sign off or exit the online session, also can. But make sure 11:45 be here back. Okay, join the session back. I will choose one of you guys in random to present your answer. Okay, is it clear?
Yes. So we only need to solve question one now, right?
Question now. Yes, yes. Question number one. All right.
Okay.
See you guys in another 19 minutes. Hello? Can you hear me?
No.
Okay. Have you
Uh,
finished your solution?
mm, question one to three.
Until 3.
To three.
I'm on the last one.
Yeah. The four right now.
Okay. Do you want me to share it, or you share it by yourself?
You explain.
Cannot lah. Ask first lah. Show your answer first lah. That's not the way to learn. I will explain later on, but you need to share first your answer. That's the deal, right?
Eh,
Okay, Khairul, you want to share your answer, or anyone?
193. Oh,
Up until
I
3.
only have it.
Who already finished up until fifth question? Fifth section.
I'm on the fifth one, but I haven't finished it.
Abu Bakar, is it you?
Yes.
Okay. Do you want to share it, or you want me to share it for you? If you want me to share it for you, then you should give me the answer, and then I will share it here.
Okay.
Is Nathan here? Yeah. Thank you, Nathan. Coming back.
So how do I share the answers with you? Because I did it on a paper.
Just snapshot it, or
Yes.
just take it, the picture, and then send it through WhatsApp. I will download it and share it here.
Okay.
Okay, this time around, maybe Abu Bakar will share his answer, but in our next activities, same like this, maybe I would like other student lah to share. Have you WhatsApp me, Abu Bakar?
Not yet.
Okay, still waiting, yeah.
Yes.
Okay, already received that one.
Yes, I sent it in the group.
Can you see the screen that I shared over here? Everyone, can you see the solution?
Yes.
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 Okay. My comment.
All right.
Uh,
Right in the file, so.
by the way, thank you so much, Abu Bakar, for sharing your solution. Maybe next time, other student will try to do the same, because I really need you guys to be active in this class so that you know that it's not just like and attending the class, but you need to be active as well in the class in order to you to get the knowledge. All right. For the first one, I think the total resistance should be 0.81 kilo ohm. 31 divided by 6 is 5.16. I think the first one is incorrect. This one is incorrect. And since this one is incorrect, means that all your answers incorrect as well.
Incorrect.
Yeah,
Yeah.
wrong. Who got the answer for total resistance? Can you shout or can you give me the values for R total?
No.
50 over 62
Jawapannya apa tadi,
kilo
sir?
ohm.
What is the answer?
The one that I didn't give the answer yet, but based on what you seen on the screen right now, I think the answer is wrong. The answer should be 0.81 kilo ohm. Oh, I did give the answer. Sorry. It's 50 divided by 62. 50.
Yeah, 50 to 62.
50 to 62. Yes, correct. And the answer should be in kilo ohm, not ohm over here, Abu Bakar. So this is wrong. And since, okay, you see the pattern of the marks that you will get. Since the first question is wrong, means that all the second section, third up until fourth section supposed to be wrong lah. Because of here in the second, although the strategy is correct. Here for section number 2, total current. For total current, what you need to do is you try to apply Ohm's law. And the voltage here is 5, yes, correct. Divide by total resistance over here, correct. And you should get a correct answer if the value of the total resistance is correct. Okay, that's for number 2. Now, number 1 and number 2, wrong in this case. For VDR at V4, what you're trying to do here is 2 divided by the R total times 5. And I believe that one also wrong. Because you are using, let me see, let me get back into the question. Right. Now, 2 means that you are using this resistor and using the total resistance of the circuit. That should be not the way to answer VDR. Means that the procedure or the way you answer over here also wrong. Definitely this one is wrong lah. And CDR at V1. CDR at V1, not CDR at V1. Be CDR at IR1. Okay.
Yeah.
And how do you calculate here? You use R total divide by 1 times this one is correct. The procedure, the strategy or the equation that you try to write over here is correct. R total divided by 1. However, since the value of R total is wrong, means that the answer also wrong. However, as I mentioned earlier, the way you calculate or your workflow to calculate using current divider is correct. You should use R total divided by the resistance over here and times the current coming out from as I total. And this also wrong. For power at V3,
I didn't finish that one.
Times, this one is I times what? 36.1 is R total. Power, okay, what I can comment here is the power should be, the unit of power is watt, not ampere. So,
Oh no, I wasn't done with that
like
one. So
sorry?
I didn't finish that one. I was still doing it.
Oh, okay, all right. You didn't finish it. Okay. By the way, if this is your answer, means that you're not going to get any marks for that, because at the moment what you're trying to do is this is current, this is the total resistance divided by, what is this? 8, right? Is it 8?
Yes.
8, yeah. The strategy that you use is wrong in this case. Okay, now only if you look at Abu Bakar's solution, only this part I will consider getting marks, because the strategy that he used is correct. However, the the value over here is incorrect or wrong. So in total, if this is 10 marks, maybe around 1 mark. Okay. 800, oh, Hadif also got 845 ohms. Yeah, I can consider that answer because the answer should be, this is based on what I calculated, is 0.81. If you try to take the what call it, I can accept the answer, 845 kilo ohm, 806.45 ohms, because really close to my answer. My answer is 0.81 kilo ohm. It's around 810 ohms. All right. As I promised, I would like to show you my answer. Where's the answer? Okay, here. Can you see the solution?
Yes.
Yes. Okay.
Yes.
Thank you. Thank you. All right. I need your response because otherwise I didn't know whether it is you can see it or not. All right. Back to the question. It says here that referring to the circuit, calculate the total resistance looking from the voltage source. So what we're trying to do here is that we're trying to get the total resistance seen from the source. If you look at these 2 points, or looking at the source, basically we have 2 branches, big branches. First one is this branch, consists of 8 kilo, 4 kilo, 6 kilo, and 2 kilo ohm. The second one is this R1, 1 kilo ohm. So these are the 2 big branches in the circuit. And what you need to do is you need to simplify. And I really recommend you guys, if you try to do the solution of your, if you try to give the solution, make sure you simplify the circuit, because otherwise it's quite hard for me to understand what you're trying to explain in your answer. So here, as I mentioned earlier, we have 2 big branches. First consists of this branch and another one, this R1. And if you look at the first branch at the right hand side, we have 8 kilo ohm and 4 kilo ohm connected in parallel. So what you can do is you can solve this one, and in my solution, I solve it to become RA. So RA here is given by R2 in parallel. These symbols means in parallel, and I show you step by step how do I get my answer. So now, since I have 2 parallel connected branch, I can use this strategy where R2, sorry, this is R3 times R2, R3 plus R2 to get what is the value of RA. Same goes to the one at the bottom of the circuit. We have R4 and R5 connected in parallel, and this one I replace it with RB. So if you look at this connection, these 2 resistors, the connection here, both resistors are connected to the ground or to the negative terminal of my voltage source. Means that I can simplify it to become like this. Do you get this point? Are you clear about this point?
Yes, sir.
Okay. All right. If you have any problem, then just say it. I will try to explain it in another way. All right. Now, you can simplifies R4 and R5 to become RB, and the way to calculate parallel connected resistors, if you have two parallel connected resistors, this is the way we calculate. So now R4 is 2 kilo times 6 kilo divided by 2 plus 6. If you look at my solution, I didn't put K over here because I already know. To avoid mistakes in your calculation, I would really suggest you guys to put like 2K times 6K, 2K plus 6K, so that at the end you will get the correct answer. Here I just simplify it because I know if I have K squared over at the top, K at the bottom, when I cancel these two together, I will end up with K over here. That's the way I calculate. But maybe to avoid any mistake in your calculation, you should put all the values correctly. So if it is 2 kilo, means you need to put it as 2 kilo ohm. All right. Since earlier that we have two branches, these two branches looking at from this point, I don't know whether I can I annotate? Action wizard, recognize. I cannot annotate. That's the problem. Okay, anyway, it's okay. Can you see the cursor over here? My cursor? The cursor for...
Yes, yes.
Okay, all right. Just follow the cursor. Maybe it's quite small, but you need to follow it. All right, now I have two branches which is connected in parallel, basically. This R1 and this branches at the right hand side is connected in parallel with this 5 volts voltage source. I can redraw it to become like this. So I just consider this is node A and node B. I can pull R1 towards the right hand side. So make sure when you try to switch R1 to a right hand side, make sure it's still at node A and node B. So now I have node A and node B as my total resistance looking from the source. So here, if you see that R1 is in parallel with these two resistors. So now to get total resistance looking from the source, R1 should be in parallel with RA plus RB. So I apply the same technique that I applied earlier. Here, R1 is 1 kilo ohm, and RA plus RB, you need to add these two together because these two is in series. So when you try to apply or you try to solve the total resistance, make sure all series resistance you should add together first, and then later on you solve the parallel connected resistors. So here R1 is in parallel with RA and RB. At the end I got 0.81 kilo ohm. Is it clear?
Okay. Yes, yeah.
Okay. I only hear the same voice, and I don't know about the rest. Maybe you should have a look, you should respond as well, so that I know you keep the pace of the solution. Okay, thank you. All right, for the total current, as Abu Bakar, from Abu Bakar's answer, I think the way he calculate total current is correct. However, the value he put into the equation is wrong. So here, this is the correct value that you should put. To calculate total current, V or voltage source divided divided by, because total current is a current flowing from the source over here, 5 volts voltage source. And now if you apply a basic Ohm law, you will get it as 6.17 milliampere. That's for total current. The third one is to get to find VR4 using voltage divider rule. Okay, sorry, can I proceed?
Yes.
Okay.
Yes, sir.
Okay. If you try to have a look at the question, basically, sorry, if you try to look at the circuit, basically there's a few options that you can use to calculate VR4. But in this particular question, you need to use voltage divider rule. Somehow, if you present your answer using other methods other than voltage divider rule, although your answer is correct, means that you won't get any marks from there. Ami, can you mute, Ami? Okay, thank you, Ami. All right. Again, if you use other methods other than voltage divider rule, you won't get the marks because the question clearly said that you need to use voltage divider rule. And what Abu Bakar tried to give the solution is that he managed to use the voltage divider rule, except that the value is wrong. But keep in mind, if the question asks about voltage divider rule, it means that you need to use voltage divider rule. And back to the question, if you look at the simplified circuit over here, basically voltage at resistor 4 or VR4 means voltage over here is the same voltage across VRB. If you look here, VR4 is voltage from this point to this point, okay? From this point to this point means that if you go up a bit at R5, the voltage across R5 actually the same voltage as VR4. If you try to combine these two resistors, although the value of resistance is a bit different because you already combined it, however, the voltage from this point to this point is considered the same voltage you've seen earlier. Or in other words, I would like to say that VRB, voltage across this point to this point, is equals to VR4. And the way we use voltage divider rule, we should use this equation where VRB is equals to RB divided by RA plus RB times 5 volts. Why 5 volts? Because 5 volts is the voltage from this point to this point. Okay, voltage from the top until the negative terminal from the source. So the total voltage across VRA and VRB is basically 5 volts. Now we would like to divide it, or we would like to find what is VRB. Okay, this is the way we calculate VRB, and this is the answer based from my calculation. I got VRB as 1.8 volts. And since we have already defined VRB as VR4, so VR4 is 1.8 volts. So this is very important. This is the tricks that you need to really understand. Although it's asking about voltage across R4, but you really need to analyze the circuit. Okay, VR4 is basically voltage from this point to this point. If I combine these two, it's the voltage across is still from this point towards this point. That's why we can say that VRB is equals to VR4 because of the rules of parallel voltage values. Okay, am I clear this third section?
Yes.
sir.
Yeah.
Okay, good. Now, for the fourth one, we try to calculate IR1 using current divider rule. Again, when the question asks about current divider rule, means that you need to use current divider rule. You cannot use any approach. For example, in this question, if you like to calculate IR1, it just simply by using Ohm's law, you can get that one, because we know that voltage across R1 is equals to 5 volts. So what you need to do, if without using current divider rule, you apply Ohm's law, where IR1 is given by I equals to V divided by R1, or 5 volts divided by 1 kilo ohm. You can always get IR1 from that. However, the question asks about current divider rule. So you need to use current divider rule in this case. So using current divider rule, you have two branches over here, and you would like to know what is the current flowing through resistor R1. So again, the step is like applying this formula, means that if you like to calculate this branch, means the numerator should be the resistor at the other branch, divided by the sum of the resistors of both branch. So here I have IR1, RA plus RB divided by R1 plus RA plus RB times total resistance, total current. So what Abu Bakar gave us just now also correct, because he used another approach. However, the approach that he used also current divider rule, where current divider rule, if you have more than 2 branches, for example, you can apply what Abu Bakar gives us just now, because current divider rule, if you have more than 2 branches, you can apply the equation of I equals to R total divided by Rx times I total. So the Abu Bakar approach is, I think, also correct. However, the answer is wrong because of the values of R total is wrong earlier. All right, now can you follow how to calculate IR1 with current divider rule using my solution?
Yes.
Yes.
Okay.
Yes.
All right.
Yes, sir.
Okay. Thank you. And for power at R3, okay, power at R3 is the power dissipated at this resistor, or 8 kilo ohm resistor. There's a few approach that you can use. For example, if you know what is the current flowing through this R3, you can use I squared times R3. Or you can also use a simple power equation where P equals to V times I. So V in this case is a voltage across, or voltage drop at R3, or voltage across R3 lah, in other words. And also you can use another strategy. Maybe you can use P equals to V squared over R, where V is, again, here you still need to find V, but you don't have to find what is the current flowing through this resistor. So that's the I think the easiest or the fastest way to calculate, because I only need the information of voltage across that resistor, that R3 resistor. So here I apply that one, because I don't have to calculate the current. Only with voltage information I can directly find what is the power dissipated at this resistor. So here I apply Kirchhoff voltage law over here. You see that VRA is voltage across this resistor basically is equals to VR3. Why? Because again, we apply voltage across from this point to this point. Basically, it's the same voltage across these two resistors. So if you try to find what is the voltage across the resistors, you need to calculate what is the voltage from this point to this point. Okay, now you can apply voltage divider rule, but I think the easiest or the fastest way is by just using KVL, Kirchhoff voltage law, where you know that the total voltage from point, let's say this is point A to point B, the total voltage across VRA and VRB is 5 volts. And earlier we already calculated what is RB. So to find VRA, just subtract the total voltage across these two resistors with VRB. So now that's why here I have VRA equals to VR3, VRA equals to 5 minus VRB. Because I already knew that the voltage from here to here is 5. I've already got voltage across this RB, and I only need voltage across voltage across RA. Now, since I've already defined that VRA is equals to R3, I can straightforward calculate what is the power by using this equation. PR3 is equals to VR3 squared divided by R3, and I will get the answer as 1.28 milliwatts. Am I clear, or are you do you have any question?
Clear.
Okay. Right. Have a look at second one. Okay. This is sort of question that you will encounter in your test. The first one, yes, of course, based on previous tests. And this is also taken from, the question was taken from previous tests, previous session. So you will expect this kind of question in your test as well. So now, since we don't have much time, I will straightforward explain to you guys what's going on in this question. All right, now it says here that in the circuit shown below, find VO using mesh analysis and power dissipated at 2 kilo ohm resistor. But forgive me that I don't have the answer for the second one. Basically, the second section I just add today variation for you guys to give problems for you guys to think about. But what I'm trying to explain here is to try to solve this first one. The first one is very crucial. If you don't know how to solve the first section, means that the second section also gone lah. All right, looking at the solution, maybe I try to put it this way. Okay, the original question is basically try to find VO using mesh analysis, and I just add some question, section to question. Right now, the question, if you have a question like this, maybe the marks maybe around less than 10 lah. But in this case, we give about 10 if this is not my question, because I'm not the one who designed this question. But if I am the designer of this question, most maybe around 5 marks for this question. But it's okay, it doesn't matter about marks, but the way we solve it is more important in this case. All right. To get VO using mesh analysis, First, you need to analyze the circuit. Where is the mesh? Mesh. So easily we can identify that in this circuit we have three meshes because it's already defined over there. I1, I2, and I3. What I'm trying to let you guys aware that if you have current source over here and over here, meaning that your the solution basically has been simplified. You don't need to calculate what is the current of I2 and I1 over here because the current is given. But some students didn't know that. They don't know that, okay, we can use this current as I1. You try to find what is I1, but this sort of circuit arrangement, for some student maybe they say, hey, it's quite easy, but for some student maybe it says that, oh, it's quite difficult because we have current source over here. But you need to really get the idea of current source in a mesh. So that's why if you look at KVL loop number 1 or at loop number 1, I1 is already been given as 4 milliampere. So the current from flowing in this loop is considered as 4 milliampere. Same goes to current flowing in this loop, also 2 milliampere. However, if you would like to know what is the current flowing through this 2 kilo ohm resistor, it will not be the same as I1 because you see here we have a junction over here. So you need to apply junction where based on this junction, I can say that current flowing through here is given by, let's see, I1 minus I3. So this one is I1 minus I3. And if you look at over here as well, this is not I2. Same goes to I4. This is not I2 because we have two currents connected together. I let you guys determine later on what is the current flowing through here. It's very important for you to know what is the current flowing through resistors because based on the question, you need to find what is the power dissipated at this 2 kilo ohm resistor. So later on, maybe you can find. I just proceed with the solution to find VO over here. So now again, my loop number 1, I1, is defined as 4 milliampere. Loop number 2, I2, is defined as negative 2 milliampere. Why it is negative? Because you see that we define our mesh current to be in the opposite direction with the current source we have in the circuit. That's why it is negative 2 milliampere. Okay, the thing that you should calculate is, or you should set up the equation is at mesh number 3. Looking at mesh number 3, we see that we would like to have voltage equation, or we would like to gather our voltage equation in order for us, voltage drop, in order for us to get the Kirchhoff voltage law equation. So here you see that this 4 kilo times 1 I3 minus I2 is basically voltage across this resistor. 2 kilo times I3 minus I1 is voltage across this resistor, and 6K times I3 is the voltage across this resistor. And later on you have minus 3 equals to 0. Okay, let's say that I try to start my equation from here. I don't know how to annotate this one. Maybe, can I? This is not the one. I don't have the function to annotate that one. Mark, remove, hidden, trip, action wizard. No, this is not the one. No, I don't have any tools. Can I comment? Okay. All right. If the current is flowing this way, means that we have positive. What happened?
Use the pencil too.
Sorry, pencil.
Ah.
Okay. Thank you so much. IT savvy, thank you. Okay, okay.
Mantap lah Naim. Let's go.
All right. Now that one is positive, one is negative. Maybe can I? Right. Right. It's flowing that way. I should label this one also positive, negative, positive, negative. Okay. Based on this equation, it says here that the equation started from this point. Okay, this point. Go around the loop and return back to that point. Okay, from here you see that we have plus 4k. Okay, where did this thing come from? Okay, looking at this junction, let me draw it here. Okay, I have I2 flowing this way, and I have I3, oops, what's wrong? I have I3 over here. The current that I would like to find is, maybe I label it as Ix. Here Ix is given by, okay, Ix is given by, let's say we start from, can I delete this one? Okay. We start again. Let's say we consider Kirchhoff current law. Sum of I in equals to sum of I out. Okay, I in this case is I3, and I out is I2 as well as Ix. Okay. Now the current that makes the voltage drop across this 4 kilo ohm resistor is basically Ix. So you need to find what is Ix in this case. So this is basically Ix. So Ix is given by I3 minus I2. When you rearrange this equation, you will get Ix. So that's why here we have I3 minus I2. Okay, let's have a look at voltage drop across here. There should be a current over here that force or that makes, that gives us the voltage drop across this 2 kilo ohm resistor. But if you try to find how do I find this I current? Okay, let's say I label it as IY. Okay. If you try to focus on this point, I think it's a bit difficult. What you can do is try to have a look at this point. Okay, look at the point at the top. You have current here as I1. You have current you define as IY earlier. IY will give us voltage drop across that 2 kilo ohm resistor, and you have I3 over here. You have I3 over here. Okay. I don't like this one. What happened over here? Okay. Okay. Okay, this is I3. So to get IY, maybe you can apply Kirchhoff current law at this point. So I have I in, sum of I in equals to sum of I out. I in this case is I1 plus IY. And I out is I3. Remember that our main target is to find what is IY in that direction. So IY is given by I3 minus I1 when you rearrange this one. So in other words, I would like to say that this equation is basically given is for IY. And for voltage drop across this 6 kilo ohm resistor is quite straightforward. This current, okay, current here is I3 and as well as current over here, because we have open circuit over here where I at this area should be 0. Okay, so all the current flowing through this 6 kilo ohm resistor, and you can say that to get voltage drop of 6 kilo ohm resistor, we should use this equation 6K times I3. And I return back to the KVL that we try to develop. First, we will have positive 4 kilo times I3 minus I2. Later on, we have positive 2 kilo I3 minus I1. Go around the loop, we have 6 kilo plus 6 kilo times I3. Later on, here you will get into negative 3 volts. That's why here we have negative 3 volts. And return back to the point, the starting point, we will equal it to 0. All right, now, since we have this equation and we have the definition of I1 and I2 already been given in the question or in the circuit, it's already there. So you can substitute I1 and I2 in loop equation of loop number 3. So that will leave us with only one unknown variable, which is I3, and we can get I3 as 0.25 milliampere. Okay. Now, how do we solve this VO? VO, again, it is a voltage from this point to this point. Okay, I label it from this point to this point. That's VO we try to find. So VO is basically the voltage drop at 6 kilo ohm plus voltage drop at 3 volts. So here, since the polarity of 3 volts is in the opposite direction, so that's why when you basically what happened over here is 6K I3 plus negative, so that will give us the value of VO. So here, VO can be found by summing these two voltage. First is voltage drop, and the second one is the voltage source over here. So at the end, we will get the answer as negative 1.5 volts. Are you clear with the solution?
Yes.
Okay, hopefully you get the message, because this is very important. This sort of question will be asked in your test, so make sure you really understand what's going on in the solution. Later on, I will put the solution in e-learning so that you can have a look at it. Maybe the solution in the e-learning is with this, all this sketching. Maybe you can rewrite it back and get the understanding by your own, or get your own understanding and compare it with the answer. Okay, now if you look at the second question, power dissipated at 2 kilo ohm resistor. Okay, can you tell me what is the way to get that one? To get power dissipated. Just tell me the equation.
P is
How do we
equal
get?
IV.
Sorry? Can you repeat your answer?
P is equal IV.
IV. Okay. Which I? Which I you would like to consider?
IY.
I1. V? Can you state the equation of V? You try to multiply voltage drop. Okay, you say that P equals to I times I V. Okay, I times V. So I would like to know which I over here. Which I? You say that this is I1. Okay. Now, what is the value of V over here? Which one? It cannot be -3, yeah? It cannot be 3.
I think we can change I square times R.
Sorry?
I square R.
I square R. Okay, I square R is a bit faster. Also, Abde Hilmi Saka also suggests that we use I squared R. P equals to Nasif Rahman already gave the answer I1 minus I3. I1 minus I3 squared times 200. Sorry, 2000, 2K. I think what Abde also Nasif suggests is correct. However, for Nasif, maybe I would like to say that try to use IY back. It's easier because we need to find what is the value of power dissipated at this 2 kilo ohm resistor. You see that this is the current that flowing through this resistor. So try use this IY back. So I would like, in my case, I would like to use this one, I3 minus I1. But since the what do you call it, the equation of power for using current, you will use I squared R. Doesn't matter whether you use I1 minus I3 or I3 minus I1, because later on you will square that value. So if you got negative value, you will square, you still got the positive value, and of course lah, if positive value, if you square, it's going to be a positive value. But doesn't matter, both answers are. So what Nasif suggests over here, I1 minus I3 squared, the value also correct. But I would like to suggest that maybe you can directly get the current over here using IY, because it already state what is the current of IY. In my suggestion, my suggestion is that I think this one also can, but if you use I1, it's definitely wrong. And I would really suggest that you use either V squared over R, okay, or I squared times R. Okay, I've already informed that you guys to use this I squared R, we will like to use this IY and square it and later on multiply it with resistor. The resistor should be, the value should be 2 kilo ohm lah. Kilo. Okay, to use this formula, V squared over R, remember that the voltage that we try to use over here is should be the voltage across that 2 kilo ohm resistor. If you look at the equation of loop 3, this is the equation, okay? This is the equation of V 2 kilo ohm, okay? Where we have I times R. So this is the voltage that we try to put over here. So V squared means that you need to square this value and divide it by the resistor value to get the value of power. And remember, power unit is watt. Okay, watt. The power, the unit of power should be watt. Okay, are you clear with my explanation?
Yes.
Clear.
Okay, all right. Any question from the floor? For those who really stuck or still stuck of doing this exercise, maybe you can ask your mates, or maybe you can have a look back at lecture notes that I provided in e-learning, how to all those knowledge to answer this kind of question. I think these two these two exercises is a very good exercise for you guys in order to digest back what's going on in the past 4 weeks. Past 3 weeks, I think. See, this is up until mesh analysis. So to please have a look back at the notes that I gave earlier and try to digest how to solve this one, try to work on this exercise back. I have another exercise, another two more questions. Maybe later on in next week, I will show you guys. As usual, I would like you guys to show your answer first. Means that you are really interested to know or to learn about how to solve. If you just ask me about the answer, I will never give you guys the answer, because you should also appreciate what people have done. So try to I try to appreciate your effort by giving the solution to you guys. Are we deal with that? Deal, eh?
Yeah, deal.
Okay, all right, good.
Yes, sir. Yes, sir.
It's okay if you are wrong. If you are wrong, then I didn't like scold you guys. Scold, it's a bit childish lah, kan? It's okay, never mind. It's the learning curve, right? If you do something wrong, means that this is the time for you guys to make it correct. Okay. See you guys. See you guys next week. Maybe next week on Tuesday, I will explain you guys about another theorem of Thevenin and Norton. And later on, if you have time, we will have session like this in part 2 to prepare for your test. Okay. Have you fill out the attendance form?
Yes.
Yes.
Based on my record here, I have around how many? 15. Another 4 students still didn't fill out the form. So I will open the form up until 1 o'clock. Not 1 o'clock lah, 2 o'clock lah. 2 o'clock, and later on I will close the form. Okay. Any question before we our session?
No.
So far,
Okay, again, as a reminder, that Adam Kushairi.
so far so good. But not so good.
Not so good. You need more practice. As I mentioned earlier, if we have around 4 hours, means that you need to spend another double the time to make to do revision. I think one of class member here already gives us share us the textbook, right? So have a look at the textbook. Many example as well as, oh, I have one question over here, Mo, asking about may I know why 4 kilo ohm resistor between mesh number 1 and mesh number 2 can be omitted? Okay, we're not omitting the 4 kilo ohm resistor. It's just that in this question itself didn't focus on the 4 kilo ohm resistor, because from mesh number 1 we only need to know what is the current flowing through here, and based on the circuit arrangement, the current's already the value of current already stated as 4 milliampere. However, we would like to know what is the current flowing through here. You need to work out this at this point. At that point, okay, at that point, you know that if you would like to know what is the current over here, let's say I put it as I. Yeah, I spend sometimes, yeah. I over here. IZ, and we have this is what I really hate. IZ, this is this is 4, and the current is 2 milliampere. So if you would like to know what is IC, you need to work on the Kirchhoff current law here. Not saying that we omit this 4 kilo ohm resistor. It's just that the question didn't ask about that 4 kilo ohm resistor. You mentioned about this one, right? In between mesh number 1, number 2, yeah, between. All right, right. Okay, if the question asking about what the power dissipated at this resistor, means that you need to calculate what is IZ and find what is the power over here. However, in this question, it just says that, it just asks about what's the voltage VO, and we already knew what is the current flowing in these two meshes. Okay, thank you, Mo. That's a very good question to get further understanding. We will see again on Tuesday next week, 9 a.m. until 11 a.m. Hopefully to see you guys all in the session. I think that's all for now. We'll see you again next week. Stay safe, everyone. Thank you so much for your attention. Assalamualaikum.
Have a good day, doctor.
Okay.
Thank you, Doctor.